The lens, kind of like the pupil, can also change shape. The difference is the pupil is a hole. The lens is actually a physical structure, right? Kind of like the lens of a magnifying glass, kind of like glass, that can refract light. So change how light rays are coming in to change where that light hits in the eyeball. So the lens can either become rounder, or flat, and then anything in between these two. That's going to allow light to refract differently and hit the eye differently. Now this changes in lens shape, which is called accommodation, because of the ciliary muscles, which are smooth muscles, this band here, that either contract or relax to cause this lens shape change. This is pulling on these fibers here. These are zonular fibers. You saw these black stuff in the cow eye. Was actually more even obvious than the ciliary muscles themselves. The ciliary muscles were covered in black stuff as well. So this contraction relaxation occurs based on where we're looking at objects, where they are, far or near, and they're going to be regulated by the oculomotor nerve, cranial nerve, their contraction or relaxation. So that's the basic idea of lens accommodation. We're going to look at a little bit of physics to understand why we need this to happen. So we care about the focal point. In our eye, we want to focus where? On the fovea. So we want our lens to be able to refract light rays onto our fovea. That's the focal point. This is showing light from a far away object, results in at lens like shape X. Let's actually do this. So shape X, like that's how fat or round it is, X, results in focal distance. Let's do X and Y. But if we have a close source, that changes the focal distance. So this is lens still X, shape X. It hasn't changed. So our focal distance is now Z. And if that was our eye, we wouldn't be able to see that image very well because it's behind our retina. So what happens is our lens changes shape or accommodates. In this case, it fattens, rounds, becomes more rounded. So lens shape is now X2. And focal distance, it's hard to see actually because my pictures are off. This should be Y again. We're back to, or actually this is a different scenario here. Let's say it's back to what we want. The point is the lens is becoming rounded to shorten the focal distance. So the lens changes shape to refract light at a certain focal point. That's the basic idea. How this looks in terms of kind of eye scenarios, this is a little bit better, similar idea, better picture. For close vision, that's over here. So we've got our lens is rounded when the thing is close. And this is because the ciliary muscles are contracted. And this is the right setup to focus on the fovea. For more distant vision, so this is like this scenario over here, we've got our lens flatter, and our ciliary muscles are relaxed. Where is the focal point? Still on the fovea. That's what we want. Of course, there's a spectrum in between this, so you can see and focus on images at far and near distances and everything in between.